did nothing wrong, and all of a sudden, one night in the morning or something, he saw his bank got like millions of coins additionally, stole from the other accounts, right? So instantly, this organization disqualified because of the issue of the software issue. Okay, same thing happened in the world, like AI. A lot of AI projects fail, not because of something like we didn't think about or something, because of those bug. Okay. So now a whole blockchain goes into like a third version. Okay, version 3. Version 1 is typical. Everybody knows it's a Bitcoin. It's a version 1. Okay. Our concept, majority, our communication, all the public documents are still talking about 1.0, which is wrong. 2.0 has the Ethereum came out as the typical example. Ethereum add a smart contract to it. Okay, so it makes the application possible, because smart contract you can think about as a workflow. Okay, so a ledger plus a workflow, so makes people think wild, and one of them is DAO, the other one is called a kitten, right? So everybody wants to find a killing application. Everybody chasing it, right? That was a couple of years ago. Okay, they want to find a huge, big one can dominate the whole world. Then what? Failure, big failure, right? Big failure. Okay, so now the industry becomes, back to the reality. They say, okay, multi-ledger might make sense, right? That means we break down the ledger, that huge ledger, into smaller ones for each organization, for each industry, and make the thing happen, could happen. The reason why the blockchain could not deal with those, let's see, right? People say it's not scalable, right? Consume a lot of resources. Okay, so now let's see. This is the Gartner's report, very lately. This is the later report. Okay, so we know every technology has a hype. It's a hype cycle, right? Every technology goes up and goes down, and if never be able to pick up, these technologies are dead, right? If these technology can pick up and go that way, it will be the best time to invest into these technologies, right? That's normal. Everybody knows. Like Amazon, goes down, goes, almost like every internet company in 2000, belly up, right? And some Google, Amazon, actually, they start going up. Okay. So based on this technology, we can see crypto coin mining technology is pretty mature. Okay, it's the right trend right now. Okay, and then this one we call the DLT, right? Distributed ledger technology, represented by Hyperledger, is also right here. Okay, so that means the ledger actually is kind of technically it's mature. Okay, but now it needs to find the use cases and put into its work. Okay, people are chasing what are people chasing right now is decentralized ID, right? If you are in the industry of blockchain, you heard DID everywhere. All the government is talking about DHS, DODs talking about decentralized ID, but actually it's in the peak. Okay, it might drop, and let's see how soon it can pick up. Okay, and other technologies they are looking at certainly is consensus machinism. Okay, they want to make sure the consensus can have, because currently the consensus only has a little bit of, we will see like few. Okay, you can have hands full, but you will see later the consensus has some big issues. And also the decentralized application is still here, right? So people actually, if you look at zero knowledge proof and all these kind of things, and the blockchain management services, Amazon has a quantum ledger DB just came out last month, right? So you can put all your data records onto that ledger, so it's immutable. And also they have other kind of, Microsoft is catching up on their Azure platform, these kind of things. Okay, so the estimate you can see, the most mature technology, it will be, these plateaus will be reached in 2 to 5 years. That means all these technology will be in 2 to 5 years. But this guy, these two, should be able to fly. I mean, not fly, stably grow. Okay. So if in an organization, if you want to deploy some blockchain project, looking at the distributed ledgers, okay, it should be pretty stable. Now there is a pros and cons. Okay. We know this is a distributed ledger. That means unique. The ledger should be unique. That means any kind of transaction on top of on the ledger, it's not double spending, right? Example is a lot of hotels, for example, if you book within our current system, you can easily produce duplicates. Okay, that's one issue. The second issue is the current. Let's give a very fundamental example of everybody, because everybody in the IT world. When you receive an email or when you receive a text file, can you 100% sure that that text file is coming from John, for example, if John sent to you? And can you 100% sure that message he said, hello, somebody, hello, Ren, can I 100% sure that is what he wrote, hello, Ren? In the current world in IT, no way, because it's based on TCP/IP, right? TCP is a broadcasting. Okay, so the TCP and contain the message, package it with the TCP, the package, right? And then with the IP, which is the destination. Okay, so it jumps to that hoop, say, can you find me to reach to that IP? And then that node is able to see, oh, I know which one could be easy, and then jump to that node. So it's basically it's broadcasting, flooding the network. Very, very inefficient. Okay. If we use the blockchain technology, it might be easier. Okay, because blockchain is peer-to-peer, first of all. If I want to send John to me, it's one hoop. Okay, that's one thing. The second thing is if we put everything on one chain, it can verify this is from John. Okay, and also the message is the only message because there is no copy. The current issue of the email is you got a copy of the message, right? So basically with the blockchain technology, we can solve a lot of issues. And certainly like, DOD is looking at, for example, typical example, Deloitte actually did one example. They use their PIV card. For example, somebody, right, a system administrator, he traveled to Vegas, and all of a sudden, the data center somewhere needs his PIV card to log on to the system. Currently, nobody, no ID, system administrator allow this kind of thing, and they did not do that, right? But if it's in the blockchain world, he can plug on his laptop in a Vegas hotel, right? We can trust that, and then remotely, he can log on, use his PIV information, right? Because right now, the bio, whatever information, nobody wants to trust. Even use your facial, recognition, use your fingerprints. If it's cross the network, nobody wants to trust. Okay, but certainly it's a big picture, right? It's certainly fundamentally it's going to change the industry. Okay, so that's why so many people, particularly in the IT, are so into it, right? Getting crazy, but the whole world is getting crazy as well. That's just one example of the IT, right? But we have a lot of issues. One issue is the transaction speed is very slow. Okay, in the Bitcoin, for example, because each block, it generates each block in 10 minutes, first of all, right? And we will see in the block, I will tell you, it's not exactly 10 minutes. It's definitely more than 10 minutes in order for the transaction to be trustable. That means finalized, to be settled. Okay, so at least we will think about at least 20 minutes to 30 minutes for a transaction. So if you go to a coffee shop and you have to wait for 20 minutes to pay your coffee, it's not feasible, right? That's one issue. The second issue is the storage. Because a lot of things are on-chain. Okay, that means the data is on-chain, and then you have to duplicate the whole thing into each node. Because the blockchain is they call it fair, right? That means all the software running on your laptop or on your node is identical to every node all over the world. Okay, how big that's going to be, right? Even with the current Bitcoin, it's only no transaction, right? Just remember the value. Okay, almost no data. It's already reached to like more than 300 gigabyte. And imagine if we put something, transaction, Amazon's transaction, all to the one node, it's not feasible again. Okay, so there is issue with the storage. And then confidential, certainly there's a lot of issues with confidential, particularly, for example, if we want to put some personal information or something on chain, and then that chain actually replicate over to all over the place, right? That is not also against a lot of regulatory rules and the laws. Okay, so that's another issue here. And also, permission also is an issue, right? And do you think DoD would allow all the information to be public and without any permission, right? But we know a blockchain has a lot of goods, but good things also has a lot of issues. Okay, but now let's go back and see how blockchain work. What is really a blockchain, right? How does it work? Blockchain is built upon, we know this, crypto, mercury, consensus, and general ledger, right? But physically on a chain, for example, this one, B1, is called, normally we call it Genesis chain, Genesis block. It's the first block. And then how the second block linked to it, right? It's the chain, so linked to it. You can see it does this one. It does a hash, okay, based on all the transactions, and then create a link based on that hash, and then puts into here. So that means only one way. Okay, all the blocks is going to be append to the next one. Okay, and then if you want to see, for example, if we want to change the B3, almost you cannot do it at this moment, right? What happened is you have to disassemble this one. Okay, you have to decode this one because it's based on the crypto. You have to decode that one first, right? It might take take about 24 hours, for example, to decode one, and then you have to decode a lot of, and in order to get back to here, and then you change something, and then put them back on, right? People say, yeah, that's a flaw, right? I can change it, but certainly based on the cryptographic, yes, you can change that. But what about consensus? How can you put the block back on? You have to go through the consensus, right? The consensus will block you again. So remember, it's immutable. Okay, immutable, right? There is no way, almost no way, unless you own this chain, right? Just like Jose in HHS, he said I can change everything because he owned that chain, right? So Jose actually is CIO. He actually built the blockchain in the government space. So, but anyway, this is the foundation. Okay, this is the foundation, and then they put all these data onto the Merkle tree. That's another kind of a secured way. So if you from the leaf, if you want to trace up, you almost get nothing. Okay, from that Merkle tree. That's why it sits on your node, and if you want to trying to decode all those data, no way, you cannot open it. Okay, so as I said, fundamentally, there is a big piece in here. It's called consensus. Okay, because each node is running on their own. They are not communicating very often, almost no communication. only when transaction happen. Okay, so let's go through very quick. For example, there's a block created, which is a transaction happen. So the transaction happened, then actually deliver into a pool, transaction pool right here. Okay, and then based on the consensus, it will pick, say, which node is going to do the register or to do the for example, Bitcoin is competing, right? A lot of everybody trying to compete to get that node, right? Get that transaction. Okay, I get that transaction, and then I trying to resolve a math issue, right? That is the crypto issue. I trying to resolve that because on the block there is a special code right there. If I can resolve that and match it, okay, I will win. Okay, so I will be the first, right? But really, people doesn't know because you might be able to resolve it. You might be able to resolve it, okay? And then once it goes, and the transaction actually, it will send it to the application, to a smart contract. And certainly the smart contract in the Bitcoin world, it's not there, okay? But then what's happening is there is a consensus right here. It will calculate, say, oh, you are the first, so I will let you to put this block on the blockchain, okay? The rest are what? The rest are wasted. So if there is based on the proof of work, if there is 100 machines trying to bid, only one win. The rest, 99 work, are waste. So that's another issue of the blockchain. People say, your waste of energy, your waste of computing power. It is, right? It's wasted, okay? And another issue is accidentally, there could be accidentally, there are 3 people solve the math problem at the same time, right? So how the system does? The system actually fork that chain into three pieces. And the rule says the longest fork will win. Okay, so there's also a lot of issues, like for example, this fork A, okay, the longest. What about fork B and fork C? It's wasted. Okay, so the consensus will consolidate all those, that's fine. But the issue is it takes longer. So that's why I said when you at the Starbucks, if you want to settle your payment, it might take longer because of the forks thing. Okay, so you guys see there's a lot of issues with this one consensus, but I will tell you more, okay? So what consensus really want to do, it's called a gaming theory, okay? The gaming theory is, this is a very typical one, and a lot of blockchain use this one called a BFT, right? Byzantine fault tolerance is a fundamental consensus algorithm. Just like AI, in the AI machine learning kind of thing, it's called a BERT, right? B-E-R-T. It's the fundamental algorithm for all the machine learnings, okay? So let's see how this thing works, okay? This is back to 20 years or 30 years, just like the same thing as AI, right? And there's there is an issue with the every computer science major, they teach this kind of thing, right? Okay, this is the old story. Two army, they want to attack one castle right here. Okay, but the only thing they can win is they have to attack at the same time. Otherwise, they will lose. Okay. Also, the message cannot be, do some like alarm or something. The enemy will get prepared, and then you will lose, right? So you have to send a secret message back and forth. Okay. Now here's the issue. Okay, this army said, okay, let's attack at the dawn, for example. That message is sent to General 2, and the General 2 has to send a acknowledged message back, right? Now what's happening? Because that message still needs to be acknowledged by the General 1. So this becomes TCP/IP, so it cannot resolve. That's why it has to broadcast, right? Endless, because each message has to be verified by the other message. Okay, that's the computing world right now. Okay, that's the same issue here. So what's happening is they found a way. Okay, so let's say, okay, the situation most likely is right here. Okay, so in the Hyperledger, let's say we have to put 4 nodes. Okay, the minimum is 4 nodes. Okay, that makes the whole thing much easier, right? And then what's happening is the consensus has to be reached. For example, like Lieutenant 1 says agree, Lieutenant 2 has say agree, Lieutenant 3 has to agree, so that that block will be certified, right? So the commander basically is the distributor. Say, okay, Lieutenant 1, Lieutenant 2, Lieutenant 3, try to validate that block, or trying to validate that contract, transaction. Okay, and then the study will be, for example, if the Lieutenant 3 is a trader, right? So he always, when you send a V to him, he always sends something else to other people. Okay, so the message is always, command send a V to Lieutenant ABC, 1, 2, 3, and Lieutenant 3 will send the wrong one because he's the trader, right? So now look at the Lieutenant 3, Lieutenant 2. He say, okay, this is a V, this is a V, and this is an X. So the consensus might still reach, okay, because that will define. That means as long as 1/3 or 2/3 of the message are correct, that consensus might reach, okay. But if commander told them before, say you have to have 100%, then you can reach the consensus, right? But not, for example, for that case, Lieutenant 2 will say no, because he got VV and X. Okay, so that's how the consensus gets constructed and gets agreed. Is based on a rule of the predefined rules, right? And another study we have to study is, for example, the commander is a trader, right? So that means he will send the message out, and send the X message to Lieutenant 1, send the Y message to 2, and send the Z message to Lieutenant 3. And then if they relay those messages, every lieutenant, you will see Lieutenant 3 will receive Z, Y, and X. So that case, there will be no consensus reached. Definitely not, right? Because everybody receives no consensus message at all. Okay, so that's kind of every situation has to be programmed into the system, and that is called the consensus. Okay, and that is the big thing on the blockchain, because you can see this is a lot of consensus algorithm produced. Okay, so let's start with the easy one, which is the proof of work. Proof of work is very easy. Just say, as long as everybody agrees, and the proof of one that doesn't like the one has the, primary has the followers. Proof of work treat everybody equally. Okay, but the question is, if it's a 51% consensus, okay, but there's a lot of issue here. The good thing of the society is really, let's see, for 10 years, right? A lot of people attacked Bitcoin, but Bitcoin survived. And it says, oh, I'm secure, but actually you're not, to be honest. How many machines in the Bitcoin? It's about 100,000 nodes in Bitcoin. If the United States wants to attack that thing, easy, right? We can build, even myself, I can attack right now, right? I can go to cloud and I can set up 1 million machines. I can easily hijack the whole network, right? At what cost? That means at what cost? that means, it's not secure at all. Okay, this is not secure, right? That's the big thing here. Okay, so people think, okay, because, first of all, it's not secure, and also the scalability and storage requirements, all those kind of things, right? So people think, oh, this could be another one. It's called a POS. Okay, it's called a proof of stake. Okay, that means how much stake you have in this organization or on this chain, and then you will have how many weight. This is very feasible. For example, in an organization, right? You want to make a decision, and you gave HR 50%. So, for example, hiring a person, 50%, and then you gave your CEO 25%, for example, and then you gave the IT, for example, 25%. Let's just say that, okay? So, and then you can define, say, as long as that consensus reached to 75%, that consensus reaches, okay? So that is a typical called a proof of stake. And it's also pretty quick because, you just need 3 nodes, right? It's not like 10,000 nodes because for the Bitcoin, it takes time for them to calculate, takes time for them to come to consensus. So now you just need to have 3 and then come up to consensus. That is going to be very easy, very quick, okay? That's why the Hyperledger came up with all different types, okay? Let me give you another one, for example, is the proof of, it's called escape time, okay, elastic time. That is particularly used for Sawtooth. Sawtooth is Intel-funded supply chain application. Okay, it's mainly trace the goods, right? Because Intel has a lot of chips made in all over the world. And then they want to use this kind of consensus to prove the, first of all, origination, and the second is the supply chain, all these kind of, I will say, from the manufacturer, logistics, to the shipment, and all these kind of things, right? And for example, if over here there is a chip, okay, they say, made in Taiwan, because Taiwan is a big chip manufacturing. And then they say, okay, took 20 minutes and arrived in San Francisco. Certainly it's wrong. There's no way in the world you can have 20 minutes from Taiwan to San Francisco, right? So that is it's called elapsed time. Okay, based on that time, it can provide some consensus or some proof. See how long does it take for that thing go, okay? And then certainly, this is for most of these 3 are for the public chain. Okay, they have to think about all these kind of, different kind of ways. But for the Hyperledger, it's more towards a centralized system. Hyperledger, a lot of people criticize, say, you are not the blockchain. Actually, it's a ledger, okay? It does have some fundamental elements of the blockchain, but it also provides some practical way to deploy the system into the organization. Okay, for example, it supports the database. Okay, so you can get your data off-chain. You don't have to save your data on-chain. Okay, that will release a lot of issues. So the cases in current practice is, it's not going to use the blockchain as really carry the data one place to the other. Actually, it provides a validation or auditing or kind of way so that you can at least trace this data. Okay, so most reality way is, for example, that's what actually FDA did, was trace the origination or of the food safety or something. They actually put the information like the farm information, all these informations, right, off-chain. Okay, but put a hashed transaction ID on-chain. So that hashed transaction, it moves around the chain. Everybody can see, but if they want to look at what's exactly inside, it provides two ways. One is the security, right? If you have the rights, you can see it. If otherwise, you cannot see it. The second way is it actually limits the size of the chain so that the chain becomes very small. So it goes very fast. Okay, so that is the most industry doing right now. And then any questions here? Okay, okay. So when you define a chain or define a consensus, sorry, these are the things you have to consider. One is the blockchain type. Okay, if it's a public chain, for example, if it's the permissionless, it's going to be a public chain, right? So you can use a POW, POS, and if it's a permissionless chain, you might want to use the BFT. Very important thing you want to look at is the finality, the settlement time. Okay, it's a finality is the one most company wants to make sure it's fast enough. Okay, so this one you see under these kind of proof of work, proof of stake, proof of elastic time, they are probabilities. Okay, so based on the consensus, 70% to reach the consensus, and then that's okay, right? Just like speech to text in the AI, we actually working on that. The error rate, as long as it's less than 40%, we will think that's the sentence you talked. Okay, in the AI. So it's very it's to be honest, it's not very accurate right now. Okay, same issue here. Okay, but really, if you want to reach a very high accuracy, that means you have to use private chain, and also you have to use the BFT or federated BFT. That's immediate. Okay, and Hyperledger actually tested the one in their lab. Brian told me, he is the manager director. Brian told me they tested the one in their own subnet. Hyperledger speed can reach to million, like 5 million transactions per second. Okay, so when you read the document and say, oh, because blockchain is not fast enough, it cannot deal with the stock transaction. No, it can. Okay, really depends on how you construct the chain, how you construct the overall structure. Okay, and then there is another one you want to look at is the a lot of people look at is the token needed, right? Because in the organization there's no token needed. Okay, people are thinking about token needed because sometimes they reward the idea. For example, there is some application actually. It's called a brainstorm, and then reward the employees with the token. That means they can use the token to their employees' discount or something, right? Certainly there's a way, but it's not the majority. The majority of the application right now is non-token. Okay, you don't have to even think about token because it's just already complicated enough, right? You don't have to involve another kind of controversial kind of concept right here. Okay, and then the scale is also very interesting. Okay, scalability of peer network. This one is high. Okay, we're talking about set up a node real quick and then scale it out. Okay, but in order to do that under the Hyperledger, for example, it's not that far, not that quick. Okay, and then let me just do this one very quick. Proof of work. If you program it, it's very simple actually, right? What's happening is see if there is a new block coming, if it is, and then you just do the calculation based on the SHA. Currently it's SHA 256, right? There's a lot of computation and there's only one match. Okay, so you do that. And then after you finish, and then you see, okay, if it's done, right? If it's done, that means if it's already exists, right? And then you don't have to do anything, right? And then if the computing hash is less than, that means you have to reach this threshold, right? If it's not, that means you did not meet the hash. That's why when you look at the Bitcoin, it always say bit hash. Okay. The bit hash goes higher, that means a lot of people are mining. Okay, if the bit hash goes lower, that means few people are mining. Okay, so when the Bitcoin price goes up, a lot of people mining, this threshold goes higher. Okay, so you have to have the computed hash less than threshold. If it's not, then you have to check if anybody has resolved the issue. If anybody resolved that, then you have to skip. Your work is done. You wasted. Okay, and then if it's not, that means you have to increase your workload and increase the. There is a nuance right there. Increase. Okay, increase the nuance and recalculate. That's how the POW work. Okay, so based on this flow chart, anybody can write the program. All right, but this has been proved, right? Somebody has to come up with this kind of algorithm first. Okay, this is what the scientists are studying, particularly the computer science professors, and the whole world actually is doing this kind of thing. They have a major, it's called a blockchain consensus, right? Study. This is a little bit complicated. The Byzantine fault tolerance is this, okay? But I'm not quite sure I want to go through this far, but just remember, the F means the failure node. Okay, F means the failure node. So in order for the maximum failure node to be reached, okay, for example, right now we say maximum failure node will be 1. You have to have 3 times 1 plus 1, so you have to have 4 nodes in your network. Okay, that's kind of you have to remember. But what happened in this model is when they say okay, replica 3 fail, it just doesn't have, the system doesn't get any message sent from them. Okay, so you can see right now all these nodes are not malicious nodes, right? It just doesn't send anything. Okay, see the distance we were talking about back in here. We are talking about some malicious nodes right here, and actually in the current science, in the current blockchain, nothing in the blockchain can no blockchain so far can deal with this kind of situation. Not yet. They are still studying, right? For example, this guy sent some wrong information. Okay, so current system just to think you are a good citizen in my network, on my network. Okay, so you see the distance from the real world and to now a lot of people still hype, right? That's called hype, right? That's exactly the hype on the blockchain, right? But people are people like me actually we're working with a lot of research and with the National Science Foundation, right? We're trying to resolve that kind of issue. Okay, so what's happening now, right? I borrowed the IEEE slides from one of the researchers, professor, and we have a lot of quantum, Corda, Hyperledger, Ethereum, and everything, right here. So that is called the DLT technology. So one of the study or one of the trend is looking at these guys has to talk to each other, right? So it's called the interoperability. That's the first thing a lot of industries are looking at, right? Not only in the blockchain itself, but certainly. But we also haven't looked at what about there's a lot of Oracle, SQL, Microsoft, and all these kind of traditional database right here, right? Data lake or all these kind of S3 or something. We haven't added these kind of things in here, right? So the data interoperability, that's one thing. And the second thing is actually the infrastructure change. Okay, so we call the multi-cloud and multi-ledger. Okay, so that means one cloud, it can sit on AWS, can sit on Google, can sit on Azure, right? So that's another industry's trend. Okay, we want to do, and also we want to piece the blockchain into pieces. right? So that you can easily deploy to the enterprises. So Ethereum has its own enterprises version now, okay? And the Hyperledger certainly has its own enterprises version. Okay, so all the CIOs now, before if you look at the 2 years ago, all the CIO was like, oh, we don't want to touch blockchain. But now if you look at the agenda on CIOs, blockchain is on the agenda. Okay, they certainly want to do some, test the water and certainly want to do some preliminary work and see which one they want to attack first. So within 2 years, that's on the agenda, also majority, okay, from the Gartner's research. Majority, the CIO wants to do something on blockchain. But certainly, the trend is the healthcare is very advanced, because they have to protect their own data, the patient's data, all this data. So HHS actually is pretty advanced on that space, and then energy as well. So the energy is also very advanced on that space. And imagine even NOAA, I talked to them, and the weather, right? They say, why we need the weather to, something. They're also looking at some blockchain project. But, I don't know how feasible that will be. So a little bit of the Lingear Foundation. It's a non-profit organization. Actually, we win there is a kind of a competition, small, like project-wise competition. That was the earlier of this year in the blockchain conference. These are the Shark Tank, and you can see this. She is a MIT professor. Actually, she leads a lot of innovation of blockchain, and she was in the Shark Tank. And these are the contact information, and we registered a lot of places, and also we offer a little bit of advising. We offer 10 weeks of class Python, with particularly in the AI space. The class actually going to be start tomorrow. Questions? So that's all from me.
One of my things that I have a hard time figuring out, right? So if I want to do this at scale, and I have, let's say, trading, right? And I have hundreds of trades a minute.
Yeah.
It sounds to me like I have a central point that can create. Otherwise, every time I create a transaction, I may be using the same head as someone else.
Yeah.
And then conflict. So it seems like I'm making this one very narrow band that everyone has to go through. So I can't understand the scaling part of this. How does it work when only one can write the actual transaction head when I have that many going on?
Right. In the permissioned, it's actually signed. Right. See, you are the prime, and then you reach the consensus. If the consensus reaches, right, and then you write. So you become the validator, and also become the register. So that becomes very fast.
Does that mean I now have multi-branch tree?
No, it won't happen. So in the Hyperledger, particularly on the Hyperledger space, there is no multiple trees. For example, actually, these are the replica, right? Mm-hmm. The primer actually will do all the work. So primer will verify that, and then the primer actually will write.
I'm doing my work. Someone else is doing something else. If I have a lot of transactions going on, that's going to be more than one prime going on at the same time.
That depends on the consensus. So if it's we say proof of work, then it's going to be competing, and then certainly there will be multiple branch.
Okay.
Yeah.
So we have multiple branches, or only one guy can do the work at the same time at a time.
Only then it will see which branch will grow bigger. So that branch will grow bigger, and then they will take that. The main chain will take that. Okay. Yeah, that's how the proof of work works. But it takes time. So a lot of like a quantum or Ripple, they are not using proof of work. They use actually this kind of consensus. So they point, say, Bank of America, you do the work, just like a liberal, Facebook, they just have 100 member, for example. So these members do the work. The other people, no, you don't have. You have to join this consortium. Yeah. So the current application, actually, I can mention a few. We actually working on the voting system, because the voting system has a lot of issues, and they also know in the rural area, people actually change the chips on the voting machine. Accidentally happen like that. So use the blockchain with the IoT devices. So when people vote, it's already logged onto the IoT device and on the chain, on the blockchain. Certainly, it's not allowed to connect to the internet at that moment. And then, once it's finished, and particularly on the auditing, so they can collect all those IoT devices, which is a node on each one, and then they can verify very quick. Because now the legislation says the auditing has to paper-based. So the lobbyist wants to change it to be paper and digital. So that digital will be very quick. And then the paper, certainly, if you want to verify, that's fine. Takes weeks or months. But at least the whole process can still going on. So that is one. And the second one certainly is another big one is the background check. Because the background check takes long time. Like right now, the secret clearance, if one guy apply to it, it will take at least 1 year to get it through. And a lot of work already wasted. For example, I worked for Booz Allen Hamilton before, and then I have my record on Booz already. And if somebody, third party, already validate my information should stay somewhere, trustable, so that when somebody, some other agencies check, and they don't have to go through, call Booz Allen and say, it's you don't have to do that.
But they don't trust each other.
Exactly. So that's why, they are thinking about put a chain somewhere. Education can get the educations, right? Harvard, if you graduate from Harvard, Harvard can issue your certification, and you just pull that certification and share to your employee. That's it. And then, on the background check, and certainly some actually more, more granular and residential, for example, residential validation and those kind of things. Once it's verified, why do you need to verify second time? So that's kind of another kind of use. And IoT, certainly, a medical device is going to be a huge, in the emergencies, something, right? And if you want to really collect all the data. And a typical example is if United States president has a emergency and somebody has to do an operation, and that surgeon is remote. And right now, nobody can do it, right? Willing to do it because they don't trust the image sent through the network, right? So if somebody hijacked that image, and then that surgeon's knife will be in a different place, right? So how can we verify those kind of things? So certainly we can see blockchain will be and fundamentally change a lot of IT, but it takes time. It takes time. And actually we are kind of hoping everybody jump in the boat and study it, figure something out. It's going to be fundamental. Thank you, guys.